Watch this. Every AI answer you have ever received comes from one of the two completely different ways of thinking. Two AI models, same knowledge, completely different way of solving the exact same problem. So why does one AI answer almost instantly while another pauses for a few seconds before replying? Is it slow or is it actually thinking? Let's find out. Most AI models, including the ones millions of people use every day, work in one straight pass. You give them a prompt, the model predicts the next token, and almost immediately you get an answer. But let's try a simple question. A farmer has 17 sheep, all but 9 died. How many are left? A lot of models answer 8 because it sounds right. But if they had stopped for even a second to check the sentence, they would realize the answer is actually 9. That's the difference. Being fast isn't the same as being thoughtful. And that's exactly where these two types of AI separate. Normal LLM predicts the next token as efficiently as possible. A reasoning model takes an extra step, actually, several extra steps. It plans, it checks, it verifies, and only then does it respond. Here's what happens inside a normal language model. Prompt goes in, the transformer processes it, it predicts the next token, and generates the answer. One clean pipeline, optimized for speed. That's why these models feel so responsive. Now compare that with a reasoning model. The prompt still goes in, but before generating the answer, it breaks the problem into smaller pieces, builds a plan, checks whether that plan makes sense, verifies its reasoning, and only after all that does it produce the final answer. Instead of confidence coming from speed, it comes from verification. Notice something interesting. Both models start with the exact same prompt, but the journey is completely different. One goes straight to an answer, the other creates checkpoints along the way. More checkpoints usually mean fewer mistakes. If we zoom in, a normal LLM follows one prediction path. A reasoning model runs several internal stages: reasoning, planning, reflection, and verification before you ever see a response. It isn't magic, it's simply giving the model more opportunity to catch its own mistakes. Let's test it with a famous example. How many letters are in the word strawberry? A model that rushes might confidently say 9, but a reasoning model actually counts them: 1, 2, 3, all the way to the 10. Same knowledge, different processes, different results. So, where does each model shine? Normal LLMs are incredibly fast. They are cheaper to run, perfect for chatbots, autocomplete search, and everyday conversation. Reasoning models, on the other hand, excel at coding, math, scientific reasoning, planning, and solving complex problems. So, which one you should use? If you need an answer instantly, choose a normal LLM. If accuracy and deeper reasoning matter more, choose a reasoning model. And if you want the best of both worlds, there's an even better solution. This is how modern AI systems are built. Every request first go through a router. If it's a simple question, it gets sent to the fast model. If it's something more challenging, it gets routed to the reasoning model. So you are always using the right model without even realizing it. So what does that internal thinking actually look like? The model explores multiple possible paths, starts eliminating the ones that don't make sense, and eventually only the strongest reasoning path survive, leading to the final answer. You are already using both of these today. General chat, normal LLM. Coding assistants, research tools, math solvers, planning agents, those increasingly rely on reasoning models behind the scenes. So the trade-off is pretty clear. Normal LLMs are faster and cheaper. Reasoning models are slower, cost more, but deliver better accuracy on difficult tasks. So here's the simplest way to remember all of this. Normal LLMs predict. Reasoning models think before they answer. And honestly, the future of AI isn't choosing one over the other. It's combining both. If you enjoyed this breakdown, leave a like, subscribe for more AI deep dives, and I'll see you in the next one.